Again, I will repeat the lesson. So here, let's start from the first. You will see that we have already our graphical way of solving or describing the image form in a concave and in convex mirror. So for the accuracy of our description, it is best that we will also use the mathematical way of solving it, which is the mirror's equation. So in the mirror's equation, you will see that the formula is the reciprocal of the focal length is equal to the sum of the reciprocal of the distance of the image and the distance of the object. So 1 over f is equal to 1 over di plus 1 over do. Your f could be solved by di times do divided by di plus do. If the image distance is actually what we are searching for, so f do, no, f times do will be divided to do minus f. And in the distance of the object, the formula will be distance of the object is equal to f di all over di minus f. Okay, the magnification is equal to m, which is equal to negative di all over do. So your magnification can be also solved with the formula hi all over ho. Now the question is, we have already the values. Now, how can we describe the location? In the location, you can have the value of the image. How about for the kind of image? How about for the size of the image and the position? So we can use this following description. So we have the quantity focal length. If the focal length is positive, so we're referring to a concave mirror. And if the focal length is negative, we're referring to a convex mirror. So in some of the problems or problem solving activities, the problem there did or stated the value for the focal length, but it doesn't emphasize the negative sign. So if the problem is telling you that it's a convex mirror, once you're going to solve for the distance of the image or object class, you have to use a negative focal length despite na wala gin emphasize sa problem nga negative. Basta convex gani, negative din ang focal length. Okay? Now, the distance of the object, if it is positive, it is a real object. If it is negative, that is a virtual object. In the distance of the image, if it is positive, the object or the image is a real image. And it is negative, the image is a virtual image. Okay? In the magnification, if your magnification is positive, that is erect or upright. And if the magnification is negative, that will be inverted. So how about on the size? On the size, if the magnification is greater than the absolute value of 1, that will be enlarged. And if the magnification is equal to the absolute value of 1, that will be same size. And if the magnification is less than the absolute value of 1, that will be reduced. Okay, let's check your or our drawing a while ago that we described the image that is formed in if the object is located beyond C, and we made a table. Okay, now so we will check that. We will going to assign values for it. So in our drawing, we put the object here beyond C. Okay, and then we located that the object is here, which is inverted, which is same reduce, which is found between C and F. That is in our ray diagram. Okay, now we will check our ray diagram if it is correct using the mirror's equation. As I said, the mirror's equation and the magnification equation is the most accurate way of describing the image. So let's assign values. For example, your focal length is 10 centimeters and of course, your center of curvature or the radius will be equal to 20 centimeters. Now, if you put the object 30 centimeters, that is already beyond C. Okay, that's beyond the center of the curvature. So let's have to solve for the distance of the image. So the distance of the image is equal to f do all over DO minus F. So 10 times 30, that will be divided by 30 minus 10. So we have 300 centimeters squared divided by 20 centimeters. So that will be 15 centimeters. So you will see that the image distance is 15 centimeters and it's located in this portion. So our findings in the graphical way of solving it is correct, that we found the image at between, I mean, the center and the focus. Okay, and the distance of the image reveals here that it is positive. So definitely this is a real image. So this is also real because the image in our drawing is found in front of the mirror. So that's real. Now the magnification reveals that it's negative, and our drawing is also correct because you can see that it is inverted. So definitely it is inverted. Now, the zero point 0.5 is less than 1. So definitely that is reduced. And you will see that the image is shorter than the object itself, right? So our drawing a while ago is correct using the four-ray diagram. Now, let's have some example. Okay, let's have some example. We have here a 5 centimeter candle is placed 40 centimeters in front of a concave mirror whose center of curvature is 60 centimeters. Describe the image form. So your DI is 40 centimeters, your height of the image is 5 centimeters, and your center of curvature is 60. So if the center of curvature is 60 or the radius is 60, definitely the focal length is 30 because the focal length is half of the radius. So your DI will be equal to FDO all over DO minus F. So 30 times 40 is 1,200 centimeters squared. 40 minus 30 is 10. You divide, and the answer is 120 centimeters. So you will see that's beyond the center because the object is located between the center and the focus. Okay? And so it's beyond the center. And it is positive. Definitely, it is real. And your magnification is negative. So definitely the object is inverted. And the size, 3 is greater than 1, so it is enlarged. So what's the height? It is 15 centimeters. So I hope that everything is clear with you and you are now ready for to answer your activity, no, that I have given to you. So you can submit it until Sunday. Yeah, Sunday, 11:59 in the evening. Okay. So if you have no question, you have still question to clarify, please raise now. We still have 5 minutes more. May question pa kita?
Kabayan sir ang drawing mag-submit.
Of course.